question says maximum depth of a binary tree. Um, yeah, given the root of the binary tree, return its maximum depth. The binary tree maximum depth is the number of node along the longest path of the root down to the furthest leaf node. So if you look at this example, if you consider 3, if you go to the left, our depth will be 1. If you go to the right to 20, our depth will be 1 as well. But then from 20, if you go to 15, our depth will become 2, so 1 plus 1. And if you even go to 7, it will again become 2. So that's the furthest. The reason we have 3 here is because we are counting this as 1 as well. So it's basically 1 plus 2 plus 3. So it's number of nodes we are counting. In case of 1, null, and 2, the depth will be 2 because we have head as 1, left node as null, right node as 2. So 1, 2 will be the longest path. So I feel like this is basically a recursive question where we want to do like a depth of search, and we want to visit all the nodes in the tree. And while we visit every node, we want to keep track of the number of nodes that we have passed through. Um, so what the reason I'm saying that is it's possible from 7 we eventually take 3 4 more uh, steps below 7. So eventually we want to keep track of all of those steps that we are taking, and the maximum amount of steps that we have taken to reach any node should be the maximum depth of the tree, right? Again, depth here doesn't necessarily mean we go down, we can go in any direction. It's just that because it's a tree, we are calling it as depth here. The time complexity of the solution should be so for every node we can take 2 steps. It's like a recursive complexity, so it's 2 to the power n, where n is the number of nodes. For space complexity, it should be linear because that's where n is the number of nodes in the tree, because we'll be using the recursion stack to store those data. Okay, so let's try to code it. So what we'll do is we'll create like a variable, say, depth, and what we'll do is we'll just put this as 1, and then also if root is none, that means that's the base case. If the root itself is none, we want to return 0 because you know there is nothing to iterate through. And then we'll create like a function, we'll just call depth of search, and here we'll just pass in the node and the current depth. Okay, and then if node is none, in this case what we want to do is we want to do self dot depth is equals to max of self dot depth comma current depth. Okay, also I think let's just do it before, so that will be our check. And then if node is none, we want to return. But if node is not none, what we want to do is we want to do depth of search, and we want to do node dot left. So we want to go to the left side of the node, and then we do current depth plus 1. That means we include the node that we have covered, and then we'll do the same thing, and here we'll do node dot right. And we want to clear one thing, that we are doing plus 1 because the node we have currently processed is not null, and we want to ensure that we are saying that we have reached a node which is not null, and we want to add that in our count. So initially when we start, we'll start with 0 current value, and as we progress, we'll keep on adding values to it. Okay, and yeah, that's it. And then what we'll do is we'll call depth of search with the root node and then 0 value, and we want to return self depth. Okay, yep. So let me know if you have any more questions.